Here we are looking at the results now for the controlling of growth experiment. We've got these results for Bacillus subtilis. We've got the results here for the disinfectants and the results here for the antibiotics. Now, this one's quite clear. As you can see, you've got the filter paper here, and then around it you've got the bacteria growing, but there's a zone, what's called a zone of inhibition. It looks a bit like a halo, but it's a zone of inhibition. And the bigger that zone is, the more effective the cleaner is. And what I'm going to want you to do is to measure the distance from the paper to the edge of the bacteria. And you want to measure to the closest edge. And you measure in millimetres, not centimetres. So I want you to measure to the nearest millimetre. You put on the agar side, put the ruler on and write down the distance to the nearest millimetre. So that's 5 millimetres. I'm trying to get the shortest distance. So 5 millimetres, that's for Dettol, so I'm going to put that on my sheet for Bacillus. 5 millimetres. But B, which is Sainsbury's alcohol, I can see that's the shortest distance there. Again, that's 5 millimetres. Ideally we'd have done this duplicate, but it would have used a lot of plates up. Mr. Muscle is a bit further. That's 6 millimetres. Now our water control unfortunately has a small halo. So I'm going to measure, maybe because I've got some disinfectant on the tweezers, that's 2 millimetres. If you notice I'm looking above, so looking above the ruler so I can measure more accurately. Now, so if you look at this, against Bacillus we can see that Mr. Muscle is the most effective cleaner. But it's not that much difference from Mr. Muscle and then Dettol and Sainsbury's antibacterial. And then you can also do the same against the two other bacteria. Now looking at the antibiotics, I've written down the names of the antibiotics on my sheet. You can see here that there are some bacteria going right up the antibiotics, and some that's completely cleared it. So if you turn it back over again, now I can say this is OX, oxycillin. There's no zone, so we'd write there 0. Okay, this one here is novabiocin, and I'm going to measure from there to there. It looks like 2 or 3. Let's have a look. I'm going to call that 2.5 millimetres. You can actually measure the nearest half millimetre. We have next to it penicillin G, again 0, because the bacteria are going right up to it. Now there's a group here which has been very effective. It's quite hard to measure the distance because they've done complete clearing. So it's in the order of streptomycin, tetracycline, chloramphenicol, erythromycin. They've all completely cleared it. We still need to give some measurement down. So I can see, I can measure from there to here for streptomycin, and that's 10 millimetres. Tetracycline, all I can really say is to the edge about 14 millimetres. What I'm going to do is write 14 plus. Okay, it's cleared it very well. Same for chloramphenicol, I'll write 14 plus. Erythromycin, I'm going to write the same. I'm not going to measure it, I'm going to write 14 plus. So all of these three are very effective. The next one is fusidic acid. We've got a small zone. I'm going to measure to the nearest part from there to there, the closest bacteria, and I'm going to call that 1.5. And if you look at the data here, okay, if you were to treat somebody with a Bacillus infection or Clostridium infection, you would use either tetracycline, chloramphenicol or erythromycin.